Okay, let's do question 7. So 7.1 says, determine f prime x from first principles. So if you see first principles, you must always remember that you have to use this formula to derive. And then they give you f of x is equal to 4 minus 7x. Okay, so we have to derive that using first principles. So let's write down this formula over here. Okay, so do you see grade 12s? This formula has three parts, So you have this part, the red circle. You have this part, the purple circle. And then you have the h at the bottom, So I'm going to do the red circle first. So f of x plus h, I'm going to do it on the side. So f of x plus h is, you take this f of x, and wherever there's an x, do you see there's the x? You replace that with x plus h. So 4 minus 7, there's only one x in this example, So this becomes x plus h. And then you remove the bracket. So 4, this is minus 7x, and this is minus 7h. And there's no like terms, So this red circle is this over here. Okay, then the purple circle over here, so this purple part, is always what was given over here. So that's the purple circle. So now I'm going to write everything again. I'm just going to write the limit as h goes to 0. And I'm going to replace the red circle is this over here. So that's the red circle. 4 minus 7x minus 7h minus, it's this minus over here, minus the purple circle is this one over here. So because I minus, I put this in brackets, 4 minus 7x. And h here at the bottom, the light blue circle just stays h. Okay, we've substituted everything. Now we're going to remove the brackets. So the limit as h tends to 0. So here, let's remove the brackets. This stays the same. This is minus 4. And this is plus 7x over h. Okay, brackets are removed. Let's see if we can cancel anything. Positive 4 and a negative 4 will cancel. Negative 7x, positive 7x. So now let me use blue. I am only left with negative 7h over h. Okay, and now I'm going to cancel the h's. So now we're not taking h out because it's only one term. So this h and that h can cancel, So once h is gone, I don't write the limit again. I just write the answer down. So the answer is negative 7. And that's how you do that question. Let's mark this question. So for working out this part over here, so you see this part over here, either this one or that one, you get a mark. So let's give you a mark there. Then for subbing it in, so we substitute it in there, that would be a mark. Then for simplifying everything, you get a mark. And then for the answer. And that's how you would get 4 marks for that question. Okay, let's look at the next question. 7.2 says we have to determine dy over dx. So we have to derive y in terms of x. And they give us y. So there's y. Let's write y down. So y is equal to, okay, so that is y. Before you can derive, you must remember grade 12, we can't have a root in our equation that is given. So we first have to remove that root, So to remove a root, let's write everything else down. So to remove the root, we keep the base. So this is the base number. And then to remove the root, we say inside power over outside. So inside is 3. And if there's nothing outside, this is a square root. So square means 2. So that is an invisible 2 that's outside. So now that there's no roots, we can derive. And this is how we derive. We say this times this is 32. And then 8, we minus 1. So that is to the 7. And then we do the same here. we say 3 over 2 times the invisible number, that's 1 in front. So plus 3 over 2 x. And then we say minus 1. And that answer there is a half. And that is it. And this is how they will mark you, eh? For removing the root, you get a mark. For deriving and deriving, you get a mark. So this will give you 3 marks. Okay, in the next question, 7.3, they give us y is equal to ax squared plus a. Our first question is we have to derive dy over dx. So y must be our subject, and we are going to derive in terms of x. So first I'm going to write the question down. Ax squared plus a. And there's no roots, there's no fractions, there's no brackets. So I'm going to derive. I'm going to derive y in terms of x. So this 2 will come here by the a. So this is 2a. And then minus 1. So x to the 1. And then plus, there's no x here. So anything that doesn't have an x, because I'm deriving x, anything that doesn't have an x will fall away. So this is a constant, so it's 0. So the answer for dy over dx is 2ax. And that's that answer. So the next question is, let's write this down. So y is equal to ax squared plus a. We are deriving a now, eh? So dy over dA. Okay, so because we are deriving a, so if you derive x, normally the question will look like that. The question won't look like that. Okay, so if I'm deriving a, can't I rewrite this as this? Plus a. Just so it makes sense. Eh? You don't have to do that. Let's take this away then. So this is still y. So I'm going to derive now dy over dA. So there's the 1. So I'm going to say 1 times x squared is x squared. And then 1 minus 1 is 0. And anything to the 0 falls away. Plus. Then I'm going to derive a. So 1, there's a 1. So this is 1. And then that is 0. So 1 times 0 is 0. Question 7.3 says they give you y is equal to ax squared plus a, and you have to determine dy over dx. Okay, dy over dx, so I'm going to write y down. Y is ax squared plus a, and I have to derive this, so dy over dx. So, okay, I'm deriving x, so 2 goes in front here, so this becomes 2a, and then x, and this is minus 1, so this is to the 1, and then plus, I'm deriving x. So anything that's not x is a constant. So a constant could have been a number. So any number, if you derive 7, it will fall away. So if I derive a, it's not x, so it will fall away. So there's nothing there. So dy over dx is 2ax. And that is the answer there. Okay, our next question is 7.3.2. Here we have to derive y in terms of a. So not in terms of x, eh? So let's write the question down. So here what I'm going to do is, normally, if we derive x, eh, we will have like y is equal to 2x squared. So can you see there's something in front of what we derive? So I'm going to rewrite this first. I'm deriving a. So I'm going to rewrite this as x squared, then a, plus a. So, okay, now I'm going to derive a. So normally we would take this 2 and times it by anything in front of x because I'm deriving x. So I'm going to apply the same principle here. You see there's an invisible 1. So take this and multiply it by anything in front of a. So in front of a is x squared. So 1 times x squared is just x squared. And then this 1 minus 1 is 0. So this whole thing will fall away. Okay, plus I am deriving a. So a is not a constant now. So there's a 1 in front times the 1 there. So this becomes a 1 and then anything to the power of 0 is 1. So there we go. That's how you would derive this, eh? X squared plus 1. Okay, let's look at our next question, 7.4. So 7.4 says the curve with an equation y is equal to x plus 12 over x. This curve passes through the point A. So A is 2 and B. Then it says determine the equation of the line. Okay, so we are determining the equation of a straight line. There, that's our question. Then they say this line is perpendicular to the tangent. So there's a tangent at point A. So remember, this is point A. So I'm going to try and explain what's happening here. Eh? So we have a curve. We don't know how the curve looks like. This curve goes through point A. Okay, there's point A, and A has a tangent. The tangent goes through A. Okay, there it says it here, tangent to the curve at A. So this is our tangent. Then we have this other line that's perpendicular to the tangent. So here, this line. This line is perpendicular to the tangent. And the question is, what is the equation of this line? Okay, so we know this point over here, the coordinates is 2 and B. And the equation of the curve is y is equal to x plus 12 over x. Okay, so that is what we have so far. Eh? So now let's come up with a plan. To get the equation of a straight line, so we need this line, eh? We need y is equal to mx plus c. So to get the equation of a line, we need the gradient, okay, which is m, and we just need a point on this line, okay? So do you see that the line we're looking for also goes through point A? Can you see point A is also on the line? So we need this full point, eh? We just have the x value, and we need the gradient. So what I'm going to do is, let's see if we can work out what B is, eh? So if you have x is equal to 2 on a line or on a curve, you can just sub in this x value to get the y value. So the curve is this. And I'm going to sub in x is 2. So y is equal to, so this is 2 plus 12 over, here's my 2 again. And then I just put that all in the calculator. Eh? You will get your y to be 8. So the point I was looking for on this line is 2 and 8. So there you have your point. 2 and 8. The next thing I need is the gradient of that line. So I need the gradient at this point. At this point over here, there's a gradient, okay? Now, another word for gradient is derivative. So I'm going to take this equation and I'm going to derive that equation, eh? So I'm going to write the equation down. But before I derive, I need this x to be, I need to take this x up. The x cannot be in the denominator, eh? So this becomes x to the negative 1. Okay, now I'm going to derive. This becomes 1. This times this is a negative 12, x to the negative 2. And if you want to rewrite that as a positive exponent, bring only this part down. This becomes x to the positive 2. So this is the expression for the gradient. Eh? To get the gradient at that point, we always sub in the x value of the point. Eh? So look at the point. Here is our point, 2 and 8. So the x value is 2. So now I'm going to take that x value and I'm going to sub it in. So there's x. So I make this 2 to the 2. And if you put that in your calculator, your gradient is negative 2. So the gradient of the tangent is negative 2. So that is negative 2. Remember, this line is not a tangent. So this line's gradient is not negative 2, eh? So now, if this gradient is negative 2 and these lines are perpendicular, then the gradient of this line is a positive. Remember, if this is a negative, then this is a positive. And if this is 2, which is 2 over 1, then the gradient of this line is 1 over 2. So the gradient of our line is a positive a half. Okay, so now we have enough information to get the equation of the line. So y is equal to mx plus c. Y is equal to a half x because m is a half. And then we're going to sub in our point. Our point was 2 and 8. So y becomes 8, a half, x becomes 2 plus c, 8. This is 1 plus c. I get my c to be 8 minus 1. C is 7. So therefore, y is equal to a half x plus 7. And that is the equation of the line that is perpendicular to the tangent to that curve. Okay, I hope that makes sense. Question 8 says, after flying a short distance, an insect came to rest on a wall. Okay, thereafter, the insect started crawling on the wall. It was flying a short distance and it rested on the wall and then it crawled. The path that the insect crawled can be described as this function. Okay, that's a cubic function, where h is the height in centimeters above the floor and t is the time in minutes since the insect started crawling. 8.1. At what height above the floor did the insect start to crawl? So remember, after a short distance, an insect came to rest on the wall. That part is not actually important. The important part is thereafter it started to crawl. So the crawling part is this function over there. So okay, 8.1. 8.1 says, at what height above the floor did the insect start to crawl? So when the insect starts to crawl, remember no time has passed. It's only starting, so no time has passed. So it means time is equal to 0. So here, I'm going to say h of 0. So not h of t, h of 0. So I'm going to make t 0. And then I'm just going to make t 0. So wherever t is, that is now 0 because no time has passed. Okay? And then if you put this all in the calculator, your answer is 36. So the height above the floor is 36 centimeters. Okay, so remember when you start, your time is 0. Okay, next question. Okay, 8.2 says, how many times did the insect reach the floor? So remember when the insect is on the floor, there's the floor. Remember it's going to crawl, floor. So here's the floor. Now remember on the floor, the height is 0. Like the height is 0 on the floor. There's no height. So here's my equation. So what I'm going to do is, I'm going to make my height 0. So this is height in terms of time. So 0. And then I'm going to solve for t. So I'm going to solve for t because I want to see at which times did the insect reach the floor. So if you solve for t here, it's already factorized. Remember, this is a cubic function. So this part is equal to 0. So t is then 6. Or this part is also equal to 0, eh? Okay? But if you have to work this out and you go to your formula, you will get no solution. So the insect reaches the floor after 6 minutes. But the question is, how many times did the insect reach the floor? So only once. That's the answer. Okay, so only once. So this cubic function has one x-intercept. Okay, done with that question. Next one. Okay, our next question, 8.3 says, determine the maximum height that the insect reached above the floor. So any maximum or minimum, we know we're going to derive, eh? So we're going to derive because we need turning points. So for 8.3, I'm going to derive. But before I derive, I need to get rid of the brackets. So h of t. So, okay, I'm going to remove the brackets. So this times this, negative 2t to the 3. This times this, plus 3t squared. This times this, minus 6t. And then this and this, plus 12t squared. This and this, minus 18t. This and this, plus 36. Like terms, negative 2t to the 3. And then this and this, plus 15t squared. Then this and this, minus 30t. Is it 30? No. Minus 24t and then plus 36. So that's our cubic function. To get maximum or minimum, we derive. So let's derive. This is negative 6t to the 2 plus this is 30t minus 24. Okay, that's the derivative, eh? So now to get the turning point, we take our derivative and we make it equal to 0. Okay, and we are now going to solve for x. So I'm going to divide all of this by negative 6. You can use the formula. So I get t squared minus, not 30, minus 5t plus 4. And then I'm going to factorize. You can use the formula 4 and 1, minus and a minus. T is 4 or t is 1. Okay, so there's two turning points, eh? Now, because this cubic function, look at the cubic function. It starts with a negative. So this cubic function will go down first, up like that. That is the shape of the cubic function. So it will have a turning point here and here. The smallest turning point, the x value is 1. So this one is 1. And the highest turning point is 4. So that one is 4. So if they ask for the minimum, it's this one. And if they ask for the maximum, it's this one. So now they ask for the maximum. So I'm just going to use that one. So to get the maximum height, remember the maximum height, this is the time at which the maximum height occurs. So at minute number 4, the maximum height will happen or occur. So now I'm going to take the 4 and sub it into my formula. Né? So remember, to get the y value of the turning point, you sub in that x value. So I'm subbing it into the cubic function, into this one over there. So negative 2, 4 to the 3, plus 15, 4 to the 2, minus 24, 4 plus 36. And the maximum height is 52 centimeters. And that's how you do that question. Let's go to question number 9. Okay, question 9 says, given is f of x, which is equal to 3x to the 3, 3x to the 3, and 9.1 says, solve for f of x is equal to f prime x. Okay, so we have to make this equal to this, and then solve for x. Okay, let's go. So we have this. So the red one, we have that one. That is 3x to the 3. We don't have this one. So I'm going to find that one. So f prime x, I'm going to derive is 3 times 3, which is 9, x to the 2. Okay, and I'm going to make these two equal to each other. Eh? So 3x to the 3 is equal to 9x squared. And now I'm going to solve for x. Okay, many ways to do it. Eh? So I'm going to bring everything to the left-hand side and make it equal to 0. And then I'm taking out a common factor, which is 3x squared. Inside the bracket, I have x minus, this is 3. And either this x is 0 or x is equal to a positive 3. Question 9.2 says, the graph f, then the derivative, then the second derivative. They all pass through 0 and 0. So they all go through the origin. 9.2.1, here's the question. For which of the graphs will the origin be a stationary point? So a turning point. For which of the graphs will the origin be a turning point? Okay, so let's see. It's 1 mark, but let's work it out. So for f of x, let's see, f of x is 3x to the 3. So to get a turning point, so to work out the turning point, you would derive this function, eh? And this function is 9x squared. Okay, then you would take that turning point and make it equal to 0. And then you would solve for x. So if I divide both sides by 9, I get x squared is equal to 0. And if I square, this is 0. If I take the square root, x is equal to 0. So, okay. Then I would take the 0 and sub it into the original. And the answer is 0. So the turning point is 0 and 0. So for which of the graphs will 0 and 0 be a turning point? Definitely for f. Okay. So just to show how I got it, eh? So definitely for f. So f tick, let me give f there. Then I'm going to do the same thing now for the derivative. Let's see. For the first derivative, let's see, the first derivative, this is the parabola, eh, is 9x squared. Let's see, what's the turning point of 9x squared? You find the derivative of that, which is 18x. And you take your 18x and you make it equal to 0. And you solve for x. So the x is 0. Then I sub it into that, 9. And I also get 0. So the turning point of the parabola is also 0 and 0. So this is also a turning point for the first derivative. Okay? Then for the second derivative, we know the second derivative is a straight line. How can a straight line have a turning point? So it's definitely not for the straight line. So the answer here, it is for f and for the first derivative. And that's the answer there. Yeah, you could work it out on the side for yourselves, but this is only for 1 mark, eh? Okay, 9.2.2 says, explain the difference, if any, in the stationary points referred to in question 9.2.1. So, the difference in the stationary points, eh? So, let's say you have a stationary point here. Okay, and then for the parabola, you would then have a stationary point here. So what's the difference in the two stationary points? The difference is this one is also a point of inflection. That's the if you have one turning point, it is a point of inflection. But with a parabola, that is just the turning point. And that's the difference. So for f, it's the point of inflection. And for the parabola, it's just the turning point. That is the difference between the two stationary points, eh? Both are stationary points. Okay, let's go on to the next question, 9.3. 9.3 says, let's read, determine the vertical distance between the graphs. So the vertical distance between the cubic and the straight line where x is 1. Okay, so what are we going to do here? So we've worked it out, eh? F of x was 3x to the 3. Okay, let me read again. So determine the vertical distance between the graphs of the first derivative, the parabola, and the straight line, where x is 1. Okay, so the parabola, the equation is 9x squared, and the not the cubic, the straight line, remember we worked it out earlier, is 18x. Okay, now they want to know what's the vertical distance between these two points. But the point is where x is 1. Okay, so I'm going to sub in x is 1 I'm going to sub in x is 1 here and then get an answer. So for the first one, if you sub in x is 1, 9 times 1 squared, I get 9. And here, 18 times 1, I get 18. So the vertical distance between 18 and 9, that vertical distance there. Remember, this point is 1 and 18. This point is 1 and 9. So the vertical distance is 9 units. So 18 minus 9 gives me 9 units. That is the vertical distance. 9.4 says, for which value or values of x is f of x minus f prime x less than 0? Okay, so for which values of x is the cubic function minus the parabola less than 0? Okay, so how can we do this? Okay, so what I would do here is I would rewrite this question. Where is f of x? Below the derivative. Okay, so now I'm going to ask myself, where is the cubic function below the parabola? You can also do it like that. Okay, so where is one function below another? We look at the points of intersection. Okay, so to find the points of intersection, I would make the two graphs equal to each other like this. And then I would bring this over and solve for x just to get the points of intersection. Let's look. So this is x minus 3. And so x is either 0 or x is a positive 3. These are the points of intersection. And remember, for these questions, you only need the x values. So I'm just going to make an example. This is not precise. So the cubic function would look like that. Okay, remember, it goes to the origin. Then the parabola would look something like that. Okay, you can sketch it, use your calculator. Then there's a point of intersection. Let me use another color. So then blue. There's a point of intersection and there. So x is 0 here and x is 3 here. The question is, where is the cubic below the parabola? So the cubic is below the parabola from here to here. So the cubic is below the parabola from here to here. And then again from here to here, it's below. So it's actually below all the way down here, this whole thing, this whole part here. The cubic is below the parabola. So it is where x is less than 3, because there's 3. But remember, there was no equal sign here. You see the 0 over here? It must be less than 0. So over here, both of them are equal to 0. The one isn't less than the other. So x cannot be 0. X is already not equal to 3. So because it doesn't include 3. So you can do the question like that. Or you can do the question, you can take this part and then you write it like this. Where is the parabola? The cubic function minus the parabola less than 0. And you do it like a normal inequality. You factorize. And then you have critical values. The critical values are 0 and 3. So then here you would say, this is always a positive. Okay? So this one is never true. This is never less than 0. So because it's a square, anything squared is never less than 0. It's never a negative. So first of all, you would write this down. And then you would say, so the only option is where x, that was now a positive 3. So it's where x is less than 3. So the only option is where this is less than 0. So x is less than 3. You can also do it like that.